Hey folks, Quilly18 here, and I know a lot of you have been waiting for Godot. Or have been waiting for me to make a tutorial in Godot. Actually, for several years people have asked for it, and I think there's no time like the present to finally address this, partially because currently the version 4.0 of Godot looks really good. When I previously experimented with Godot, it was an older version. I was like, I'm not quite sold on it, but now I think it is in a fantastic shape. I haven't poked around extensively in the 3D, although I'm impressed by what I see. Yeah, it's not Unreal. Let's be realistic about that. It's not the same as that. But for most like indie level content, it's going to be fantabulous, and the 2D tools look great. So I'm very excited to be poking around in here. I've been spending a couple of weeks sort of learning my way around Godot, and I'm very happy to be bringing this tutorial series to you as we remake the classic Asteroids game. Always a good idea, even when you're learning game programming, to start off with, to start with a classic old game that you can just clone rather than try to make your own thing from scratch, because then that way you don't have to deal with game design at the same time as you're doing game development. Much better way to learn, in my opinion. I am going to make quite a number of references to how things might be done in Unity while we're learning how to do things in Godot, because I'm sure there's a lot of people watching this that are going to be coming from Unity, because that's where most of my tutorials are. So hopefully that doesn't annoy people who are just here for the pure Godot stuff. Without further ado, let's go ahead and get started. If we switch over into Godot, if we load it for the first time, we get something that looks roughly like this. Note, I am operating on version 4.1.1. Theoretically, later versions of Godot should be pretty similar to this as well, hopefully. We're going to create a new project, and I'm going to call this project Astro, Roid, Rage. I'm going to leave everything default. I'm just going to create my folder, create and edit, and that's going to go ahead and launch. And it's a pretty quick launch, I have to say. After trying to load up Unreal or the more recent versions of Unity, you really appreciate how quickly the Godot engine launches, which is great. First thing we're going to do is we're going to set up a basic scene for the world to exist in. We do have a few different tabs at the top of the screen. We've got the 3D editor mode over here, is which we're looking at. We've also got a 2D mode over here. We've got a built-in script editor. There's also an asset library that you can access to see a bunch of different things. You may have to go through the support options here just to be able to see some things, but some extra tools that are available if you so desire. We're going to be working, we're going to be making 2D games, so we're going to work in the 2D visualizer over here in the editor. Unlike in Unity, there needs to be an explicit root node to your scene. You can't just have a bunch of game objects with parent equal null kind of thing. There needs to be a single root node in your scene from which everything else will descend. There are some handy dandy buttons to create your root node for your very first scene: 2D, 3D, user interface, and then other node. What this will do, starting with say 3D here, this is the closest equivalent to what Godot would have as a game object from Unity. A node 3D is a node that exists in the scene that has a transform with X, Y, and Z coordinates. The other equivalent that we can do, if I delete this and create a 2D scene instead, it will start us off with a node 2D, which is basically exactly the same, except its transform only has X and Y coordinates. If I go and delete that as well, so there's a user interface option. Basically, this is still just working the 2D scene. It's just, instead of starting with a node 2D as the root node, it starts with one called control, which is part of Godot's user interface system. And this actually highlights the fact that your root node in your scene can actually be of any type of node that the game supports. There is a large number of options that are available as your root node. Now, when you're making a scene that is a scene, a lot of these won't make any sense. But when you're making a scene that's a prefab, a lot of these do make sense. If you're coming from Unity, you're used to the concept that there's a difference between a scene and a prefab, but realistically, there's no reason there should be a difference. Scenes and prefabs are just files on your computer that represent some game objects, and they are equivalent. They're the same thing, really. There's no reason that you have to think about them in different ways. And in fact, in Godot, there's no difference. There's simply scenes. What I will refer to certain things as prefabs, but I'm just talking about scenes. There's just a single type of object called scene. They could have just called it prefab. They chose to just call it scene. That's the way it's going to be. For our scene that is a scene, our main scene over here, again, a lot of these types of nodes wouldn't really make any sense. A node 2D makes a lot of sense because we're going to be working in 2D, but do we really want the root node of our scene to be something that can move? Because a node 2D has a transform, which means it can be moved. Instead, I propose that as a best practice, I suspect for your actual sort of main scene, the root node maybe should just be the node type. The node type is extremely simple. It's got basically nothing going on. Over the inspector, you can see here, it doesn't even have a transform. It cannot be moved. And I think that makes a lot of sense. So I'm going to rename this node. You can right click and choose rename. You can see it's also got the F2 hotkey, which is what I'm going to be using generally speaking. I'm going to call this main. I'm going to save this. I'm going to hit Control S to save. And by default, it's going to name the file the same as the root node, main.tscn. Makes sense to me. I'm going to go ahead and save that. You can see in my file system over here, I now have a file called main.tscn, and that is my main scene. At this point, I can try to play my program. If I hit the little play button over here, it will give me a message because I've never selected a main scene. This is the scene that will automatically be loaded when you run the game. It's going to be the thing that runs every other scene in your game. You know, typically that will be maybe your main menu, or maybe even like a loading screen that then goes into the main menu that then goes into the game itself. For now, I just have a single scene, so I want this to be the main scene. Conveniently, if you have the scene open, you can click Select Current, but you could also instead hit Select over here. It'll give you a file dialog. Also, as it was indicated in the little toolbox over here, you can also go to Project, Project Settings, and then under Application and Run, that's where you can choose your main scene. Whatever way you do it, you will end up with a main scene, and then if I hit play, it now runs. I mean, it's an empty gray box. It's not a very interesting main screen, but it is running. You can see that my main.tscn is now highlighted in blue. This is to show you visually what your main scene is. You can also change the main scene by right-clicking and choosing. It's not an option now because this one's already set, but if I had another scene in here, I could right-click and say set to main scene over there, which is very convenient. Okay, let's go ahead and create our player. So what I'm going to do is I'm just going to pop over. I'm using Kenny's amazing Space Shooter Redux Creative Commons 0 graphic pack. There'll be a link down in the doobly-doo for you to copy that. And I'm just going to go ahead and import a file called playership1blue, and we're going to make that into our active player. Now, I can go ahead and what we're going to do, if you can recall back to this little thing, I'm going to make our first player implemented as a basic Sprite 2D version. This is going to get completely rebuilt later on. This is not the right way to do things for our game, or in fact, I would suggest most games, but it's what we're going to do first, just so that we know why it is wrong. I can create the player's object simply by dragging the ship into the scene. Now it is visible. In fact, if I hit play, we will see it in there. Great stuff. What did it actually do? Well, it created a new node under main. It named this node playership1blue because that's what the file name is, but it is of type Sprite 2D. I could also have done this a different way. If I go ahead and delete this, under main, I can add a child node. I can right click and choose add child node. I can also, with main selected, hit this little plus over here. And as you can see in the tooltips, you can also just hit Control A to add a child node. You can add a node of a variety of different types. You can navigate this tree if you want, but you can also just type in Sprite. There you go. Sprite 2D is what we're going to do. So this creates a new Sprite 2D object. Sprite 2D, which you may have been able to identify here, is descended from Node 2D. So Node 2D is the thing that's got to transform with X and Y coordinates. So our Sprite 2D will also have a transform with X and Y coordinates, but also it'll have the ability to take in a texture, take in an image that to be displayed. So we've created our Sprite 2D, it exists in the world, but there's no visual component of it. That's because the field over here in the inspector for a sprite is currently empty. Now, we can set that by clicking over here and choosing one of the ways to make a new texture. We can also go ahead and use load, which will open up our file viewer with images, including the icon.svg that is always in the default project. When you create a project, you get a little Godot icon for you. We can choose the player ship here. The other thing you can do is in the pull-down menu, you can click Quick Load, and that will allow you to get this filtered list of things, which is very easy to search, and it'll look through subfolders over here as well, which is really convenient. For example, under my resources, I can create a new folder called Graphics, and I'll drag the player ship in there. There you go, for a little bit more organization. And now, if I use the regular load dialog box, you can see my graphics folder. I could go in there and click, or if I use the quick load version, you can see here, it just searches and finds them all. So it's got the player ship in there. So I can select that. And finally, the other thing I can do is I can just drag this over into there as well. Now we've got our sprite, and I can go ahead and move it wherever I want, which is just, as we can see here, changing the value of the transform, which is lovely. All right, so we've got a ship. We can put it wherever we want. Let's go ahead and try to apply a little bit of logic to this ship. Let's make it move around. And for that, we're going to have to go and attach a script to this. Now, it is very important at this point to note that in Godot, unlike Unity, you can't just hang an arbitrary number of components onto your game object. That's not how things work in Godot, and that'll be very obvious when we get to the next step. But for now, we're going to go and attach a script here. So how do we do that? Well, over in the inspector, you can see a script slot over here. It is currently empty. Any node in your tree can get a script. Even a main here, like our node that's got like nothing going on it, you can still attach a script to it, and we will later on. But for now, with our sprite 2D, which I'm going to go and rename to player, right? That's going to be the name of the node, but it's still of type sprite 2D. I'm going to go and add a script. So again, I can click empty. I can click new script over here. The other thing you can do is you can create a script just whenever you want in your file system here. You can create a new script, and then you can go and drag that script onto your node. And also on the player itself, in your scene view, if you right click, there's an option for attach script, which leads you here and lets you either open an existing script or make a new one, which is what it's set up to by default. By default here, it's going to set my language to GD script, which is what we're going to use for this tutorial. If you are running the .NET version of the Godot engine, you will also have an option here for C#. And with the GD extension, you'll have options for C and C++. And people have also worked on, third-party people have worked on support for additional languages as well. You're not restricted to GScript, but we're going to use it here. We're also going to use the built-in editor. You can also use VS Code and Visual Studio. And in fact, if you're working in something like C#, you're probably going to want to use those external tools. For GDScript, there's some nice advantages to working inside the built-in editor, as we'll see as we go forward. You can also mix and match your language as much as you want. You can write some of your code in GDScript, you can run some of it in C#, whatever suits your project best, depending on your use case. We're going to leave everything the default. We're going to inherit from sprite 2D. The template, we're going to leave the default template in here, but we could also generate just an empty file, or we could have no template whatsoever, but we'll use that. And the file name is going to be player.gd. Sounds great to me. Let's go ahead and create it. So what it does at this point is it flips us over to the script tab. Still got the 2D view, still have the script over here, and we can start editing. You can see our script has, because of the template, it's got a couple of functions ready to go for us. It's got the ready function, which is going to be called once when the player is first enters a scene tree, so when the player is first spawned or instantiated. And then we've got a process function over here that runs every frame. Now this is every visual frame, so depending on how quickly you're rendering to your screen, that could be 30 times per second, it could be 144 times a second, and if you don't have VSync on, it could be thousands of times per second. I will contrast this with another function that we'll see later on called physics process. This runs for every physics frame, for every tick of the physics engine. This is equivalent in Unity to fixed update. And it works exactly the same. Here, instead of being run every visual frame, it's run on a fixed tick rate, which I think is it's 60 frames per second. By default. So every 60th of a second, this will be called, and that's generally where you want to do your physics stuff, but we'll get to that later on. For now, we're going to go and do a very basic implementation of moving our player sprite around in a way that we're going to completely gut later on, but hey, what the heck, right? So every frame, we're going to want to do something. We're going to want to check to see, is, for example, left arrow being held down? Then rotate counter clockwise, right? That's say list this kind of logic. We want left and right to rotate. We want the up arrow to thrust forward, because that's how the classic Unity games work. So how do we do that? Well, we are going to use an if statement with the input class, and there's a variety of different things available in this input class, but we're specifically looking for is action, and we're looking for one of these. Is action just pressed and just released will return true if and only if the key was just hit down this frame. If it's the first frame that this key was held down, or if the first frame this key was released, then those will return true only then. Is action press is actually what we're interested in over here. Is action press will return true if the key is being actively held down, which is what we're looking for. While you're holding down the left arrow key, do the rotate counterclockwise. So is action press is what we're looking for. Now this is going to require a string, which is the name of the action. Now, we could read directly from the keyboard. We could be reading directly from the keyboard to see if the arrow keys are being held down or something like that. It is, of course, a terrible idea, generally speaking, to read raw input from the keyboard. Instead, you want to use some sort of input manager, if at all possible, so that you can easily remap keys to different things, so you can read multiple keys, so that you have ready support for like controllers and joysticks and things like that. And that's the case, say, in Unity. That's also the case here in Godot. We're going to go and set that up now. We're going to go to Project, Project Settings, Input Map. There are a bunch of built-in actions, which is what we were seeing in the little autocomplete a second ago. But we're going to go and just create our own. I'm going to create Rotate Left. I mean, I guess it should be called Rotate Clockwise, Rotate Counterclockwise, Thrust Forward. That makes sense. So clockwise, we're going to hit plus to assign a key. I'm going to hit the right arrow key. And we'll also be ready for WASD. So we want to hit the D key over here. So clockwise is your right rotation. Counterclockwise is going to be left arrow and the A key. And the thrust forward is going to be the up arrow and the W key. And I guess while we're at it, let's add a fire action that is going to be mapped to the spacebar. So that way we can shoot. Pew, pew, pew. All right, so we've got those actions registered here. So now if I come back over here to input is action pressed, because we're working inside of the Godot editor for GDScript, we've got this really smart autocomplete that's tightly integrated into our project. And this is the value of using the built-in editor as opposed to a third-party, an external editor for GDScript. Obviously, external editors have some powerful support for other behaviors, but this tight coupling with the editor is really, really convenient with GDScript. So we are going to go and listen for rotate clockwise, and we're going to do something. Let me put in a little placeholder. Oh, and also, I always forget my colons at the end of my if statements because I'm not used to coding in this language yet. And in fact, I'm not experienced with Python or anything either. So this like white space as structure is crazy. Where are my curly braces? Anyway, I digress. So we're going to want to listen to clockwise, counterclockwise. Oops. That's not how we spell that. Counterclockwise, and also fire. And again, we got this great autocomplete for things in here. These are the things. Oh, sorry, not fire. We're actually working with thrust right now. We'll deal with fire later on. Right now, we're just dealing with motion. So what are we going to do? Again, we're doing a very basic interpretation on our sprite here. All we're going to do is rotate our node is really what we're doing. Because we descend from node 2D, we have access to all kinds of different values on our game object. By the way, what we're working on here is actually a class with some class functions. This class currently has no name. It is some unnamed generic class, let me put this back in, that is running on our player object. We can actually give it a name if we want. My awesome class name. And this is important if you want to be able to refer to this class from other scripts. But generally speaking, the fact that this class has no name is not a problem in any way whatsoever. But I did want to note that we are doing object-oriented programming with classes. These are not global functions in any way whatsoever. Okay, so back to rotate clockwise. What we want to do is we want to change the rotation. Now, we can do it. We've got, because we're node 2D, we have something called rotation. We could do rotation plus, or equals rotation plus some value. We can also do the plus equal mechanic. That works fine. But we do have a function called rotate. And, you know, I always assume that if there's a function for it, maybe there's some extra sanity checks or something else going on. So rather than write to rotation directly, we'll use the rotate function. I don't think there's actually a difference in this particular case, but I also think it'll look a lot nicer for us to just rotate. And this takes in a rotation in radians. Everything in Godot is in radians as opposed to degrees, although you do have functions to convert between the two if you want. So we're going to go ahead and define some sort of rotation speed. I guess it could be a const, but theoretically, maybe there's, I don't know, power-ups or something that can change your rotation speed. Maybe you can get debuffed to something that slows you down. So we'll define it as a variable. And yeah, we'll just call it rotation speed. And this needs to be a rotation. So this is going to be a rotation in radians per second. So radian pi is 180 degrees. And 2 pi, or tau, is a full circle. So we're going to say we can do a full rotation every second. Maybe that's too slow, maybe too fast. We'll change it later. That's going to be fine. But we're going to rotate based on a rotation speed. But right now, this would do a full rotation every frame. We don't want to do it every frame. We want to do it at a rate of per second. So we're going to multiply by the delta. Excellent. I'm going to go and copy this here, and our clockwise is going to be negative. And let's hit play and see what happens. Rotate, rotate. Excellent. Looks good. Now, for our thrust forward, what we're going to do, and again, this is not accurate for how your movement is going to work in Asteroid, but it's going to be our first pass. We are going to be looking to change our position. And again, we've got access to something called position because we're descended from node 2D. And we could do, you know, some sort of plus equal with some value. But we also have access to a function called translate, which is exactly the same. It's the same as adding an offset to our current position. Here, we're just feeding it to a function. And to me, that feels a little bit better. So let's go ahead and define our speed. So this is going to be our like thrust speed. And this is going to be, if we're working in 2D, we're putting in a number of pixels here. Whereas in 3D, obviously, they're just using unit like coordinates in world space, which I think generally speaking, you tend to consider as one world unit equals 1 meter. But yeah, in 2D, we're working with pixels. 400 pixels? I don't know. some amount per second, right? So we're just going to say we're going to translate. Now, how are we going to do this translate? Translate needs a vector that is a direction. Well, if we look at our image by default is pointing upwards. So what we can do is we can feed in vector2 dot up, and then we're going to rotate this vector based on our node's actual rotation. So now we're going to get a unit vector. So it's going to have length 1, but that's going to be facing the direction that our ship is actually facing. We're going to multiply this by our thrust speed. And then again, we're going to multiply this by the delta. So we're going to get per second. And if I hit play, up works. Yeah, there we go. Cool. So we got a little bit of basic movement of a sprite. Obviously, this is not how your ship moves in Asteroid, because in Asteroid, your thrust is actually accelerating. When you let go of the forward action, your ship keeps moving. As long as you're thrusting, your ship will move faster and faster and faster and faster, and will continue to move. That's how the movement works in Asteroid. We're going to want to go and do that. Now, I will tell you, obviously, there's no reason we couldn't do something like have some sort of a variable here called current velocity, which starts off as a vector2.0, right? And then each frame, rather than translating directly, what we're doing is we're changing our current velocity, and then we're feeding our current velocity into the translate. And then all of a sudden, we've got kind of physicsy enabled movement. We can 100% do that, and maybe for this game, that would actually be the best, most lightweight way of doing it. But Godot has, of course, a physics engine built into it. And since our player is going to move in kind of a physicsy manner, why don't we just go ahead and use the physics engine to do that? Plus, it'll give us a good opportunity to learn. So that, if I go and bring up my little photo here, is going to be the plan. Step 2 is going to be to rebuild the player as a rigid body 2D. And then we're going to add in some asteroids that are also going to be rigid body 2Ds. These are going to be physics enabled objects. And it's going to feel pretty good. So we're going to wrap up the episode here. Thank you very much for watching. If you're new to the channel, of course, make sure to subscribe so you don't miss anything. And in general, like, favorite, comment makes massive difference for the YouTube algorithm. And if you check the description, you can see other ways to support the channel. In fact, both my channels, my channel where I do Let's Plays over at Quill18, and the one where I do occasionally program tutorials Quill18 creates. There's a Patreon link down there. Much appreciated. I'll see you next time. Bye-bye.